Let's talk about using the distance formula to find the length of a line segment on a coordinate plane. So here's the distance formula right here. Radical x2 minus x1 squared plus y2 minus y1 squared. Now the distance formula comes from the concept of right triangles and the Pythagorean theorem. So if I look at this line segment here, AB, I can look at this line segment as being the hypotenuse of a right triangle. And if I just complete the legs here, this leg here, and this leg here, here I can see how AB is the hypotenuse of this right triangle. Here's my right angle here, my right triangle. Now, why do I want to do this? Well, I want to do this because I know how to use the Pythagorean theorem to find the length of the hypotenuse in a right triangle. Because in the Pythagorean theorem, this tells us that the length of one leg squared, A squared, so this is going to be A, plus the length of the other leg squared, B squared, so that's going to be this leg down here, is equal to the length of the hypotenuse squared. And the hypotenuse is always C. So if I find the measure of this side, it is 6 units long, and the measure of this side, it is 8 units long, I could use that information to find the measure of my hypotenuse. So this is A and this is B, so A squared, this is going to become 6 squared plus 8 squared equals C squared. Then 6 squared is 36, and 8 squared is 64, and that equals C squared. Then we add these two together and we get 100. Now, the answer is not 100 because 100 is C squared. I want C. So the square root of 100 is 10. So the measure of line segment AB is 10 units long. So then what is the purpose of the distance formula? The purpose of the distance formula is so that you could find the length of any line segment on a coordinate plane without having to draw the right triangle, and even without the coordinate plane, all you really would need would be the ordered pairs of the two endpoints of the line segment, and you could use this formula to find the distance. So let's go ahead and check that out by looking at line segment AB again. First, what we need is to write the ordered pairs for each point. So A is at -1, 9, and B is at 7, 3. Now, you notice here the x2 and the x1 and the y2 and the y1, and this might look familiar to you from slope formula. And it's from the same thing. It's the fact that since we have 2 points, then we have 2 x values and we have 2 y values. So what we want to do next is we want to take one of the points and label it as x1, y1, and we want to take the other point and label it as x2, y2. Now that we've done that, let's go ahead and plug this into our formula. All right, so we have here, first we have x2 minus x1 squared. So my x2 is 7 minus my x1 is -1 squared plus, and then y2 minus y1 squared. So my y2 is 3 minus my y1 is 9, and that's squared. Now we're going to go ahead and work this out. So 7 minus -1, that's going to be 8 squared, plus 3 minus 9, that's -6. We've got to square that. And so 8 squared is 64, and -6 squared is 36. And hopefully you can see where this is going. And 64 plus 36 is 100. And the square root of 100 is 10, just like we got when we performed the Pythagorean theorem. Now let's take a look at the length of line segment CD, and we're going to do this one without drawing any right triangles or anything. So first we want to find the ordered pairs for each point. So point C is at -6, -5. And point D is at 8, -2. Once again, we want to label one of these points x1, y1, and the other point x2, y2. And now let's go ahead and plug this in. So notice I'm just setting this up. So we have x2 is 8 minus my x1 is -6, and y2 is -2 minus my y1, which is -5. And so let's go ahead and work this out. We have here 8 minus -6, that's 8 plus 6, so 14 squared, plus -2 minus -5, that's -2 plus 5, which is 3 squared. Now, 14 squared is 196, and 3 squared is 9. Then we add those together, and we get radical 205. Now, the square root of 205 is an irrational number. So in this case, we're just going to go ahead and we're going to round it to the nearest tenth. So if I find the square root of 205 on my calculator, I'm going to get 14.31782, blah, blah, blah. So I'm just going to go ahead and I'm going to round this to the nearest tenth and say that it is approximately 14.3 units long. So what if we have a line segment that's not even on a coordinate plane? Can we still use the distance formula? And the answer is yes. So if you look here at line segment EF, where E is at -8, -1, and F is at -1, 2, let's go ahead and find the length of this line segment. Once again, we want to start off by labeling x1, y1, and x2, y2, and then we're going to go ahead and plug this in. So x2 minus x1 squared plus y2 minus y1 squared, and we're going to plug this in. We have x2 is -1 minus x1 is -8, and y2 is 2 minus y1 is -1. So here, -1 minus -8 is -1 plus 8, so this is 7 squared. Plus 2 minus -1 is 2 plus 1, so this is 3 squared. 7 squared is 49. Plus 3 squared is 9. And 49 plus 9 equals 58. Once again, 58 is not a perfect square, so the square root of 58 is an irrational number. I get 7.6157 blah, blah, blah. So if I'm going to round this to the nearest tenth, this gives me approximately 7.6 units long. All right, I hope that this video helped you to understand how to use the distance formula.